Hi, this is Brian, president of NPART again, and today I want to talk about the difference between magnetic attraction bonds and covalent bonds, or what we call electron sharing. Um, those are some big concepts, and I'm not a chemist, so I had to take some time and figure out how to represent this with everyday things. Now, I have a wife who's a magnificent cook, and she has lots of stuff in her kitchen, and I found this bowl and some everyday plastic wrap. So if you've been in the kitchen with your wife, or maybe you cook yourself, that kind of seems odd. Um, anyway, the cling of a plastic wrap, we're familiar with that. That's a magnetic attraction, or what we call a van der Waal force. That was a big term for me. Van der Waal was the guy who defined this sort of clinging force, and that's what much of our materials use to stay on. For instance, the old cellulose lacquers on older trumpets. The reason why they would float off is somehow when we put them in warm water, it would neutralize this van der Waals attraction, this van der Waal force, and the lacquer would come off just like this plastic wrap. So that's not so good. The products that we're dealing with use a covalent bond. And covalent bonding is when two molecules or two atoms share electrons. Now electrons, I just learned this recently as we were developing these products and studying. Electrons have multiple layers of, or I should say, atoms have multiple layers of electrons. And in our case, the coating molecules in stop rot will reach down into the brass molecules, the copper and the zinc, to the second, third, fourth levels, mostly in the third level, but some in the second and fourth level, and that's more like Velcro. You can see this is a much stronger, much more tenacious and robust bond, because in the Velcro, the hooks reach down into the loops. Well, that's something like a covalent bond. And so when you coat your horn with stop rot, those molecules reach in and grab onto the brass, and they're going to stay there for a long time.